All right, welcome to some trigonometry, and we're going to talk about the unit circle and some common exact coordinates. This is ultimately going to be material that you're going to want to memorize, and you know how much I'm not a real memorization person. There's some things to understand. I'm going to show you the understanding behind it, but this is going to be material that's going to serve you well to take the time to memorize it. So what we're looking for is on our unit circle meaning the radius is 1. I think perhaps you can see these. This is a 1 here, this is a 1, we're over here at -1, we're down here at -1. That's why it's called a unit circle. It has a radius of 1. What we're looking for are common exact coordinates that lie on that circle. So for instance, right here we have 1, 0. That's pretty simple. Right up here we have the point 0, 1. Pretty simple. Over here, -1, 0, and down here, 0, -1. But now let's talk about some of these others. For instance, at pi on 6, or 30 degrees right here, what's going on? So I'm going to go back to geometry days with this, and I'm going to use some space up here. Let's say we have a nice 30, 60, 90 right triangle. Some values that we might commonly associate with that might be the short side is 1, the long side is 2, and the middle length, the longer leg, is square root of 3. That I'm assuming you've brought to this class with you. You can go through a Pythagorean argument with that. There's a lot of ways to get around that, see what's going on. But anyway, that'd be great, except when I draw this triangle into this 30-degree angle, this is not 2. This is, however, 1/2. Or excuse me, this is 1. The hypotenuse is 1. So if this is 1, if this length was 1 in a similar triangle, the ratios would stay the same. 2 is to 1 as 1 is to 1/2, as √3 is to √3 on 2. Meaning the coordinates of this point right here are to the right √3 on 2 and up 1/2. They're to the right √3 on 2 and up 1/2. It's worth noting that square root of 3 on 2 is certainly bigger than 1 on 2, and we're over farther than we are up. Okay, let's venture on to pi on 4 here, or 45 degrees right at this spot. So if I was to draw 45, 45, we go back to geometry days, and we might say that the sides that associate with this, we like to use 1 and 1 and square root of 2. The problem is the hypotenuse on a unit circle is 1. So we introduce, if I make this 1, how do we get from √2 to 1? We divide by √2. So this would be 1 on √2, or √2 multiplied by √2 on √2, √2 on 2. Likewise, this would be √2 on 2. So on this unit circle, to get over here and up here, we go over square root of 2 on 2 and up square root of 2 on 2. And now let's look at this pi on 3, which is equal to 60-degree angle. I'm going to draw 60, 30, 90. Don't really have to do it again because I could just transpose the triangle up above, but this is 60, this is 30, this is 90. From geometry days, we might like to say this is 1, the hypotenuse is 2, and the longer leg is square root of 3. But the hypotenuse needs to be 1. 2 is to 1, as 1 is to 1/2, as √3 is to √3 on 2. So to get up to this point, I go over 1/2 and up √3 on 2. Over 1/2 and up square root of 3 on 2. Now, we could go around the rest of the triangle and redraw triangles, but this is going to be really easy for us. I'm going to ballpark where these same reference angles are. What I'm going to try to illustrate to you is, yes, you're going to have to memorize, but you don't have to memorize the whole circle. You just have to have some understanding. If I know the quadrantals, and they couldn't be easier. And I know these, and notice, these are just reverses. Well, how are we going to remember when 1/2 goes with square root of 3 on 2 or vice versa? Well, remember, this is bigger. Over farther than we go up, over less than we go up. And at, excuse me, and at 45 degrees, over just as far as we go up. So not too bad. So this point would be the same distances from the origin as this. This would be 1/2 square root of 3 on 2, but we go to the left and up to get here. And this point we go left and up to get there. And this point correlates to that point, but we go left square root of 3 on 2 and up 1/2. Whereas in this quadrant we go left and down. So left, this is my long, to get to this point, this is my long distance to my short distance. So that's square root of 3 on 2, 1, but they're, 1/2, but they're both negative. Just like this point, only left and down. Just like this point, only left and down. Negative square root of 2 on 2, square root of 2 on 2. Left and down. Negative square root of, it's that point. Negative 1/2 and negative square root of 3 on 2. Short, long, negative 1/2, negative square root of 3 on 2. So to get to this point, long distance, square root of 3 on 2. Short distance, down 1/2. Equal distances, that's when it's square root of 2 on 2, square root of 2 on 2, but we are to the right and down. Short to long, 1/2 to square root of 3 on 2, right but down. So my point being, I really believe we can have this whole thing memorized if we just know that sector right in there, because the quadrantals could not be easier to find those ordered pairs. So it's really just about knowing this and this relation, this relation. Obviously this is the 45. So this is our 30, 60, 90. This is our 30 and our 60, but long to short gets me x to y. Long x gets me my 30 degree, and short to long gets me the tall one. There's our 60. So when you're asked questions like, give me sine of pi on 4, it is just square root of 2. How far up is it? Square root of 2 on 2 to the hypotenuse 1. It's opposite. The opposite is here, hypotenuse. That's square root of 2 on 2. How about cosine of pi on 6? Cosine of pi on 6 is adjacent over square root of 3 on 2 over hypotenuse. It's just square root of 3 on 2. And after we start observing this for a while, we realize that the sine of theta is just the is just the y coordinate. And the cosine of theta is the x coordinate. So if I want the sine of this angle, which would be 122, it's just square root of 3 on 2. If I want the cosine of this angle, it's just negative square root of 2 on 2. If I want the sine of the angle down here at 180 plus 45, 225, it's just the y value, negative square root of 2 on 2. Worth noting, there's a lot of other things we could talk about as far as we could talk about all students take calculus, which means all trigonometry functions are positive here. Sine is positive here. Notice the y values are all positive. Tangent is positive here. That's because tangent is sine on cosine, or tangent is opposite on adjacent, which is my x and y. If they're both negative, this is negative. then tangent becomes positive, negative on negative, negative on negative, negative on negative, negative on negative. Cosine's positive here. Notice the x values are always positive. So a lot of good information there, but most definitely worth having those values memorized. So when we just cruise around, it's like farther right, a little bit up. Just as far right as it is up, shorter left, farther up. Okay, you got some work to do to get those things memorized, but the payoff will be huge for the next couple of years.